Okay, let's continue with our discussion about the sampling. Step number 4, determining a sampling method. You can look at we have two different categories of sampling methods. On the left side, we have probability sampling, which consists of 4 different types of sampling methods. And on the right-hand side, we have a non-probability sampling methods. We also have 4 different kinds. We'll go over one at a time. Now let's talk about simple random probability sampling. Simple random basically it's a sample selected by assigning a number to every element of the population and then use some method for randomly selecting elements to be included in the sample, such as random digital diary. So if you look at on the right hand side, we have a skip interval equal population size divided by sample size. And let me just use another document. Okay, use a concrete example to illustrate this process of simple random sampling. Let's say our population of interest is Cal State Fullerton students. We have 40,000, and the sample size is 400. It's like 1% of the population. And the skip interval, as you can see, we can figure it out. The skip interval equal population size 40,000 divided by 400 equals 100. So that tells you that every 100th student would be put into the hat, into the sample, basically. So this is a very simple process. And obviously we can number each student from 1 all the way down to 40,000. And then, if we know which numbers make up the sample, then we can definitely pull them out of the list. And the process of getting that random number lists, it's very complicated. We used to have statisticians to figure it out, but nowadays we pretty much using a process called random.org. We used to have paid statisticians to generate random numbers, but now we can just generate the numbers on our own. And it's all you need to go to random.org and then go to the number section. I mean, they have lots of different things. All we need is just get to the integers, right? Integers. Okay. We need to generate how many? 400. Okay. Now, and then each integer should have a value between 1 to 40,000. Okay. And then, so we get the 400 random numbers from 1 to 40,000. And then we format in 4 different columns. We click on the get numbers. There we go. We get 5 different columns, and those are numbers. Those are the random numbers between 1 and 40,000. Obviously, we can just draw those numbers from the list. We get 400 numbers, 400 random numbers. And let's go back to the second probability sampling, which is called systematic. As you can see, systematic it's very similar, but it's in a different way because we figure out the probability of selection. If you see, it's a reverse of the skip interval. It's kind of sample size. Let's go to the say. Okay, now we can do like this. Okay, so skip the probability of selection equal sample size 400 divided by 40,000 equals 1 out of 100 is like 1%, right? So it's a probability of 1%. So basically that we can select a random starting point, random starting point. Let's say we select from random starting point. You know, you can actually get a number like random number digit, but let's say we want to be very specific, which is where do we start? You cannot. I mean, you can just probably pull a number like number 500. We start with number 100, and every 100 we get a number, right? 600. So all the way up to the coming back to from to the loop. So we have, let's say, generate one number. I mean, if you want to be very precise, we pick one random number by selecting. So let's go. Which number is lucky number? Okay, we get this 6869. It's a random number. We start from 6869, and every 100th number we get them put into the sample. So that's another way of doing the get the systematic sample. Okay, and for the third type of probability sampling, and we have stratified, and for the cluster, the fourth type of cluster, these two different kinds of probability samples, their sampling are very complex. Now, I don't want you to get too much into it. All I want you to know that stratified cluster, they belong to the camp of probability sampling. So that's all I want you to know. And because they're kind of complex, so I don't want just you guys to spend too much time on this thing. So just remember that. Okay, so this belongs to probability sampling. Now we come to the second camp called non-probability sampling. First one is called a coder. Coder, we know that we preset a number of elements, right? So basically, we can base upon some kind of demographic or other classification factors selected by the researchers, and for example, we can say we want to make sure that our sample, like 400, reflecting the general makeup or composition of the calcium fluid is 40,000 student population. So let's say we say, well, 22% Asian student, okay, and so and 20%, 22, about 22, I think about 22% of white students, and then so basically we preset the kind of numbers, make sure that those respondents make up somewhat representative of the general of the population, and respondents are not selected at random, in the sense that if the code is not met, we'll get more students belong to that particular category into the sample. So pretty much the factors are really up to the researchers. Basically, research determine how to set the quota. Okay, so this is something that it's kind of arbitrary. That's why it's a non-proper sample. Second type of non-proper sampling is called snowballing. Snowballing it's kind of like a very interesting way, especially in the age of social media and social networks. I mean, we can just snowballing, getting more respondents. And in fact, when you do your online survey, probably you want to encourage your friends on your social network to pass your survey link to get more people into your sample. And usually snowboarding also ideal for low incidence or rare population sample. And basically, like we, for example, if you want to find uh, out more about Native American students on this campus, and you probably start with someone who are Native American students, and then just let them pass a message, just get them more into the sample. Snowboarding is really an effective way of reducing costs, obviously, and but obviously there's a downside. Because when you have this kind of like snowboarding word of mouth, they tend to get the similar people, kind of. So it's not going to be representative. And the third category is called judgment sample. So judgment sample, a sample in which the selection criteria based on the researcher's personal judgment about representativeness of the population and the study. The researcher select who should be in the study. For example, we do test market sampling, okay, and taste test at the mall, taste test at the food events. So it's really up to the researchers to decide who should be included in the sample. I mean, that it's all the criteria kind of predetermined by the researchers. In a sense that judgment is similar to quota, but the only thing is that the quota is really have a preset number of respondents. And by far the most popular sampling method is called convenience sample. Convenience sampling usually because we survey people who are easily accessible or try to find people in a low residence, hard to reach category. So convenience basically whoever we can find at the most convenient locations or the lowest cost. For example, we use employees as sample group, or at the university we often use students as a sample group. Or sometimes we can just get the respondents by using more intercepts at either high traffic locations. So convenience samples by far the most popular one. Let's look at the sampling error and non-sampling error. So as you can look at so basically what we're doing here is that instead of doing census, which is try to get information on everyone in the population of interest, instead of doing that, I mean, it's going to be time consuming and expensive. So what we do is that we use sampling to get the data. So we use sample to infer the population parameter. For example, we want to figure out some of the values about the population, and then we can do some calculation based upon the sample mean. For example, sample mean, we use symbol x with a bar at the top equal mu, which is the true population mean. And then including some of the noises, sampling error and non-sampling error. And we in previous lectures we talked about sampling errors, because sampling error coming from the fact that the process of sampling, since it's built-in bias, because because of we sampling process basically has that kind of error, and the bigger the sample size, the smaller the error. And then remember we talked about if you want to reduce sampling error by 50%, you have to increase your sample size by 4 times. Okay, so it's obviously if you originally you plan to get 400 respondents, and all of a sudden if you want to reduce the sampling error you have to get 1,600 respondents, which is going to be very expensive, especially if you use telephone interviews. But obviously, you can see if you use online method, it's not going to be significantly different. Because the serving cost of online is going to be, it's going to be not much big difference, assuming that you do it by yourself. But if you commission a third-party research firm, they're going to charge you based upon the number of respondents. It's pretty expensive process, and one respondent could cost you a couple of dollars. So just to make sure that it's not as it's not a kind of cheap way of increasing the sample size. It's once you increase the sample size, you're gonna get your research. You're gonna get very expensive. Now, there's another type of error or noise. It's a non-sample error. It's called a measurement error. This is actually coming from the whole research process, and basically we have all kinds of measurement errors, which we have discussed earlier in our lectures. We have, for example, if you have interviewer bias and there's error, and you have respondent bias, there's error, and then obviously you have the processing error, and you have also if it's a survey and you have the survey inherently has some of the problems, the questionnaire design problem and also flow, also problem associated with measurement, which is has nothing to do with sampling itself. So that's why we have we have those kind of errors, and obviously the difference between professional researchers and amateur researchers that with professional researchers probably we can control measurement error or non-sample error to a minimum, right? Okay, so that's kind of a slide. Step number 5, determining sample size. Determining sample size will be based upon factors such as level of accuracy you want to achieve. For example, we talked about earlier, if you want to increase your sample accuracy, reduce margin of error, then you need to probably significantly increase your sample size. And obviously, you also need to how much money, how much time you have to do survey, and also determine upon the sampling collection method. Now, determining sample size, there's a chapter actually in our textbook. It has lots of statistics involved. I don't want you to go too much into it, but scientifically, we do need to have someone to do the calculation to figure out sample size. And as a rule of thumb, even if it's like a convenient sample, if you get a 300 respondents convenient sample, and you can get a pretty good sense of the general picture, of about what you want to find out, and 300 is a pretty good number to have for a convenient sample. Step number 6, develop operational procedures. But once you decide which type of sampling method you have and determine sample size, you need to sit down to develop a plan to, especially operational procedures. Probability sampling, they're very, very complex. You need to be very detailed, clear, and make sure that especially if you have interviewers involved, make sure that you try to limit interviewers' discretion as much as you can, and make sure that the selection of specific sample elements are conducted according to your criteria. All right. Number 7, execute the plan. Execution of the plan of the plan. I mean, obviously we talk about administrating this questionnaire. If it's online research, obviously it's gonna send out the link. If it's mailers, you need to go through the mail system. or sometimes you get making phone calls or do the more intercepts. So it varies. Basically, what you do is that get in touch with your respondents and start the gathering information. Use your survey questionnaires. And again, talk about the field work. I mean, if it's a probability sample is required or is used, really you need to make sure that the field workers carry out the instruction precisely. And many times, probably you need to do some training, and also supervise the field work personnel. Okay, all right. So that's like 7 different steps. We have some discussion questions. I want you to identify the sample design. And number one, we talk about the names of 200 patrons of casino are drawn from a list of visitors for the last month, and a questionnaire is administered to them. So what type of the sample design is? We have 8 different kinds. Obviously, we have comedians, not we have probability sampling and non-probability sampling. First of all, you need to make a decision whether it's probability or non-probability. And number two, a radio talk show host invites listeners to call in and vote yes or no on whether handguns should be banned. Okay. Number three, a dog food manufacturer wants to test a new dog food. They decide to select 100 dog owners who feed the dogs canned food, 100 feed the dogs dry food, and 100 feed the dogs semi-moist food. Number four, a poll survey men who play golf to predict the outcome of a presidential election. Okay, now, which one is which? Number one, obviously, it's convenience, right? It's whatever is available. Number two, again, it's convenience sample, right? Basically, whoever is calling in, you just vote yes or no. Number three is the quota sample. Number four, it's judgment. Okay, basically. All right. So that's all for our discussion about sampling. See you next time.